At the center, that's pointing to that.
That's what it is. We put the negative in the wrong spot. Yeah, the negative's in the wrong spot. The negative's in right here. The negative 2, positive, negative x 2. Because look, this is positive, right? This is negative. This is going to be negative 12. Positive 6. X is negative and negative 2. That's going to give us 8x minus 12 x squared.
Negative? No, x minus x.
So then you get...
to calculate the rate.
6. So how do we find the root? 6 equals x. And 6, 0. And then negative 2 x. X is going to equal 2.
Okay, so let's figure out how we can get y equals 0. So put 0
Actually,
for y, and then what's our equation? Remember I gave you guys an equation.
Equals 16.
That's the only equation I gave you, so that's all you have.
Negative. It's 32. And then
wait,
negative 12.
do I just copy that down?
16,
So yeah, you just want, because you don't,
and
where you're writing negative 1, you don't know what that is, right?
28.
You don't know that. We're trying to find what x is when y is 0, because that's the roots.
Y equals
And that's
4.
one of the bonds.
Oh, okay.
Alright guys, take about 30 more seconds to finish working with your tables. Alright, so we don't really know how we find x for this, right?
4, 0, 0, and 4.
Remember we have a squared plus b. So yeah, we don't really know how we're going to find our roots here. So what's another way we could find our roots? Like, besides just doing it.
The red 6 is 4.
What are roots?
I don't really know what they are, but I know how to
Okay. Can you, if I draw a graph, can you tell me what they are?
The roots?
So if I draw my graph like this, what are my roots? Point to it. So wherever they cross the x-axis, right? Here and here. So if you were able to graph this, we learned how to graph this, right? Would you be able to point to the roots on a graph?
Yeah.
Okay, awesome. So I'm going to give you a graph paper and see if you guys can.
Come on, it's positive.
As you get positive.
Alright, eyes up here.
No, it's already a negative.
It's okay if you're not completely done. This is kind of just like more about the process.
We're trying to save our teachers, okay?
Okay,
That's
I
a
know.
very big
You
deal.
want to save your teachers. Alright, I want to hear from a few different tables I didn't really talk to. I didn't really talk to Derek's table that much. What did you guys come up with?
What did we come up with, gang?
Just give me like something.
They plotted the points.
Plotted what points? So the graph?
Yeah, no, the roots. I think they found the roots.
Found the roots?
Yeah.
Why are those important?
Because
Say that again, Bella? That's where what's going to hit? The bomb. The roots are where the bomb is going to hit, right?
The roots are? Really?
So think of x being, or right here, y being 0 as being the ground. This is where the bomb's going to hit when y is 0, okay? So
yeah.
that's why we want to know the roots, right?
Right.
How did you guys go about finding those?
We did x equals negative b over 2a.
Okay.
We got our, what did we do? We found our a, b, and c to plug them in.
What's A, B, and C, Gustavo?
A is 1, b negative 1, and then b is 8, and c is negative 12.
Awesome. Alright, so what am I doing when I'm plugging in this A equals negative B over 2A? X equals negative B over 2A. What is this? I'm solving for what? X of what? Specific point, the vertex, right?
Right.
So, I'm just wondering, like, what do you guys think is important about finding the vertex? Why are we doing that?
We need to know what the highest point is, right?
Yeah, why do we need to know that? What do you think? You guys just told me that it was important to find where the bomb lands, but you didn't tell me anything about this.
It's so you know what the highest point is?
Why do you want to know that?
So you can run off the island faster.
Okay, so you can see the bomb coming. As long as it's important to you, then I'll go ahead and find it, but I don't want to do all this work if it's like, I don't even need to know that, right?
So much effort.
I know, it's a lot of effort. I have to like divide and do this negative stuff. I don't want to do
We're
all
trying to
that.
save you people. I mean,
Okay, so you're just gonna work and do all of this stuff to save us. That's cool. I like that. Wait, speak up, Daniel. Speak up.
If you know how high the bomb is in the air, you can calculate how much time it's going to take to come down.
Ooh, I like that. How do you know that?
I don't know.
You just know that it's gonna be possible.
Yeah.
Okay, so we're just gonna find it just so we have the vertex, we can see how much time it took to get there, and then probably calculate how much time it took to get down. Okay, I like that. We'll go with that. So Nancy, if I have all this information, this A, B, and C, how can I plug it in to find my vertex? This is the formula for the x-coordinate.
Plug in A for A and B for B.
Okay, so what would it be? Instead of negative b over 2a, I'd have
Negative 8.
negative a, perfect.
Over 2 parentheses negative 1.
Beautiful. Alright, so negative 8 divided by 2 times negative 1 is?
4.
4. Why is it not negative 4?
Because negative divided by negative.
Negative divided by negative. Awesome. So this is done. This is my vertex 4, right? No, it's just my x. So what do I have to do, Marco?
You plug it back to the original equation.
What's the original equation?
It's y equals negative x squared plus 8x minus 12.
Awesome. Okay, so Carlos, how can I plug this 4 into my equation to find the y?
You substitute 4 for x.
Okay, what would that be?
Y equals negative 4 to the exponent of 2 plus 8 times 4 minus 12.
Awesome. Alright, so this is where it gets kind of tricky with this negative 1 times 4 squared. You guys remember the order of operations, PEMDAS, we learned at the beginning? Alright, so what does this E stand for?
Exponent.
Exponent. So Jesus, am I going to take the exponent 4 to the second power first, or am I going to multiply it by this negative 1 first?
Multiply like 4 times 4.
Multiply 4 times 4, so I'm going to do the exponent first, right? Okay, so what's 4 times 4? 16. And then I'm going to multiply that 16. Multiplication comes second. 16 times negative 1 is?
Negative 16.
Negative 16. That trip anyone up?
Nah.
You guys got it? You remember
Yeah.
this? We got order of operations. Alright. 8 times 4 is?
32.
Minus 12. Alright, so negative 16 plus 32 is?
Negative 28 minus 4.
Negative 16 plus 32?
Positive 4.
16, right? 16 minus 12 is?
Positive 4.
Positive 4. Alright, so what's my vertex?
4.
4, comma 4. So the highest point the bomb will be is at 4, comma 4. So do you think me and Miss Wen and Miss Campion and Mr. Gallegos have like a coordinate plane that we can like look at? No? So these probably represent something, right? What do you think these numbers represent? The vertex, but...
The highest or the lowest point where the bomb's going to be at.
Right, but in terms of like real life application, like how is that going to be helpful to us?
You know what like the midpoint is?
You know what the midpoint is, but I'm looking, so you're going to have to like ask me another question. I didn't give you a piece of information that's really important, right? Right now you know like the point of a coordinate plane, but what do you need in real life, right, Derek?
How big the island is?
How big the island is, or like some kind of
Measure.
distance, right? You need some kind of like distance or like timing, or hey, Ms. Guenard, I don't even know what the x-axis is, what the y-axis is, all of that, right? Because in real life we don't just have like x and y-axes like we just did in science. We have, remember what was our x-axis when we were doing enzymes? Temperature or pH levels, and the y-axis is what? The enzyme what? Efficiency, right? The efficiency of the enzyme. So in real life we have like actual names for the x-axis and y-axis. So for this one, I'm going to say that the x-axis usually represents time. So we'll say it's time. It's time. So we'll say at 4 seconds,